Forecasting review. We had such fun when we first did this at the beginning of the term that we want to do this again. It appeared in midterm number 1, forecasting bit on the final. Because we get to use Excel, get to kick it up a notch. So we're going to just do this quick little review in case, because the beginning of the term is, so long ago. Okay. So we're going to talk about a couple of big forecasting tools: weighted moving average, exponential smoothing model. Those are going to be our two big concerns moving forward to the final. They're also two of the three most popular forecasting tools used out in the so-called real world, the third one being linear regression. So we're working with net income from Best Buy here. And so let's start off our journey with finding the weighted moving average. And let's look at that weighted moving average for, let's say, 4 quarters. Capture a year, capture a season, okay? Because this is quarterly data. I'm just going to select 4 cells above that WMA, and that's where I'm going to put my results for each of the 4 quarters. The order of each one of these weights is going to be in the same order as we see the date structure, okay? The most recent quarter is closer to the bottom, the least recent quarter closer to the top. Okay. One big constraint on those particular weights is that the sum of all those weights has to be equal to 1. So I need to set my sum up, a sum on all those weights. I'm going to constrain that to be 1 when I get into solver. So now, because I'm going to use 4 weights or 4 quarters to try to predict the next quarter, that next quarter is the 5th quarter. So the very first forecast I can make is for the 5th quarter. And to do that, I'm going to use a wonderful little function that we saw when we first did weighted moving average, and we saw in Finance 113, Introduction to Quantitative Decision Making, and that is the sum product function. Okay? Essentially, we'll take each one of those weights, multiply it by their respective quarter, and then sum them all up. Very, very useful. Thing is, those weights don't change. No matter which 4 quarters we're looking at, which period we're forecasting, the weights remain the same. So we need to absolute reference those weights, and we do that by pressing the all-powerful F4 key, comma, and then I select the 4 immediate preceding periods. I leave that relative reference because I want that to change when I copy this cell down into the other quarters. Close that bracket, push the enter button, go back to the cell, bottom right till my cursor is that little dark plus sign, left click twice, copy that formula all the way down. Awesome. So next step is we need to come up with an error calculation. Let's start this process off with the MSE. So we're going to talk with the MSE. And to do this calculation, so MSE is essentially where we take each of the errors, okay, we square it, then we add them up and divide by the number of quarters. Okay? So mean means we're finding an average of the squared errors. Squared errors. Now, what is error? Error is demand minus forecast. So there's actually a very neat little Excel function that'll do some of this calculation for us. And if we go sum, so I'm thinking the numerator here, and I go XMY2. What does that mean? X, demand, minus Y, which is a forecast. And then I square it and sum them all up. That's essentially the numerator for my MSE calculation. Right there, one function. Very nice. Very, very useful. So I sum up my demands. So I select my demands as my first argument, comma, and I select my forecasts as my second argument. Awesome. Making sure they match. If they don't, Excel is going to kick out an error message at you very, very quickly. Then I'm going to divide by the number of quarters that I'm looking at, which I can use the count function. count 1 quarter, 2 quarter, 3 quarters. So we're looking at column or C12. I'm just going to do demands to C72. And it doesn't matter if I count the demands, doesn't matter if I count the forecast, it's going to be the same number. But I just did demands because it's just easier for me. Okay, push enter. There's a very high mean squared error right there. So I've got my error calculation set up. I've got my constraints set up. I've made my forecast. I got the formulas all set up there. Now I'm all set. So I go to data. I go to solver. I select solver. Okay. Set objective is to set wherever I have that mean squared error calculation as my objective cell. Okay. So Excel is looking for a formula. So it's looking for a cell with a formula in it. I want to select to minimize that error. The default was to maximize. I don't want to maximize error. Changing cells, which cells, wherever my weights happen to be located, I put them in yellow so that I can see them nicely and easily. And then I add my one constraint, and my one constraint is that those weights must equal to 1. Not less than or equal to 1, but equal to 1. I click OK. GRG nonlinear is what I want. This is a nonlinear model. I want to make sure that those make unconstrained variables non-negative box is checked. The weights must be 0 or higher. Okay. Click solve. No error message. This is nice. And there I have my results. Okay. Interesting result here is the fourth most recent quarter seems to have the highest weight. Right? So whatever happened 4 quarters ago seems to have the highest impact. This may indicate a seasonal effect. So quarter 2 is very similar to the previous year's quarter 2. Quarter 3 is very similar to the previous year's quarter 3. Quarter 4 tends to be similar to the previous year's quarter 4, and so on. And so it kind of suggests there's a certain seasonality to this pattern. Okay. So we have that. Now let's do a couple of error calculations for this. One of them is mean absolute percentage error, mappy, and the other is CFE, cumulative forecast error. Cumulative forecast error, a little more useful. MSE, MAD, those are two really, really useful ones, and ones that we typically use when we're trying to minimize error using solver. Mappy kind of gets lost in the crowd. You could easily use mappy in place of MSE, but it's probably not as good. And here we'll see that it's going to be kind of tricky, right? So wait for it. So mean absolute percentage error. So that's going to be a value. It's going to be a single value. I'm just going to put it above the word mean absolute percentage error. And one of the things we're doing is we're taking the absolute, right, percentage error, and absolute percentage error just means absolute value of ET divided by DT. And then we're going to multiply that by 100. Okay. So we're just going to keep that in mind. That is essentially what we're doing in these kinds of calculations. Okay. All right. So we can now calculate that for every cell for which we have both a demand and a forecast. Okay, so for mappy, we're going to go equal to the absolute value of the error divided by demand times by 100 to express it as a percentage, and then take the average of all these absolute percentage deviations. Okay, so it's equal to ABS, and then bracket. Now we note that the denominator here is error, so I'm going to do that as a calculation within this absolute value operator, so second bracket. Error just being demand minus the forecast. Close that bracket. That's our numerator. We're going to divide it by error. Now divided by demand. We're going to divide by demand. I'm going to leave that demand within the absolute value operator. Most of the time, it doesn't matter. Most of the time, you're dealing with sales or quantity sold. Extremely rare that that's a negative number. This case is a little different than those in that here we're dealing with net income. And net income can be 0. So we want to express this as get rid of all the negative values. So we multiply it by 100 to express as a percentage, and then I click enter. Copy that all the way down. Corner, double click. Now scroll down looking for weird numbers because there's one quarter here where Best Buy didn't make any money. So I'm just going to quick and dirty just enter a 0 in there. Okay. It's just an uncalculable number. Essentially we just want to ignore it. Okay. And I get rid of this div 0 here because there's no corresponding demand related to that particular forecast. Okay, now I'm all set. Holy cow, looking past there. Whoa, there's a forecast that was really wrong. Okay, so now let's take the average. So equals to the average of all those calculations. Control Shift down, close the bracket, boom, boom. All right, and I get 225%. Okay, so clearly something's gone pretty badly with this particular model. We're missing something, right? There's either an overall trend that we're not capturing with our weighted moving average model, other factors at play. Something is definitely happening that we're not capturing with these models. And so perhaps other alternatives might be more appropriate. A trend-adjusted exponential smoothing model might work. An exponential smoothing model in general might work, which we'll do next. There's clearly something else that fits. We capture some of the flow of net income here, but we're not capturing all. Now, net income's a little tricky one versus sales in that there's typically a lot of other things that are at play. Okay, anyway, pretty interesting result there. Go to forecast errors. Okay, so we have that as well, and that is forecasted errors. So cumulative, so it means equals, we're going to find the first error, demand minus forecast. And then when we go to the second one, is equal to its demand minus forecast plus whatever is accumulated in the previous quarter. Everything's all relative reference because I'm going to copy this down. Copy that all the way down, and I see what's my bias. So it looks like I've got quite a cumulative forecast here, a little bit of a bias. Now, this is demand minus forecast, so it just means that the actual demand is quite a bit ahead of our forecast. For the weighted moving average, if I want to get the forecast for that next quarter, which is going to be funny, we're forecasting a drop, actually, $360 million is the net income. I'll be interested to see how that turns out with the COVID-19 disruption. Okay, so here we have mappy, we have cumulative forecast errors. We're all good to go. Now, one thing we'll do, we'll finish up with an exponential smoothing model. And as I just going to go to the next sheet, I copied the quarter, the date, and the millions of dollars onto another worksheet. And we'll do the exponential smoothing model on this one. Okay, so we have our exponential smoothing model. And for this one, we'll use a slightly different formula. Okay, so one of the important things in that exponential smoothing model is alpha, right? That's our kind of our key deliverable. I'll just highlight the cell where I want that alpha to be. And for this one, let's use the mean absolute deviation. Okay. Now, to find that mean absolute deviation, it's easier just to find the absolute deviations on their own and then find the average of those. So in this one, I'm just going to find the absolute value of those errors, absolute values of the errors, and then find the average of those absolute values. Now, our regime so far has been to, because we need to start off with an initial forecast, we've used the naive method in the past. I'm just going to use the naive method here. Nothing says that that's any better or worse than anything else. You could use any of the judgment methods in order to start this process off. There's nothing magical about the naive method. Okay, so I'll push enter. Okay, so this is my first one. Now I work with the formula, which is in your textbook, which is in the slides, which you probably should have in front of you when you actually go to do this on your own. And that equals to alpha times by the previous demand plus 1 minus alpha, 1 minus alpha, right, times by the previous forecast. Now, some things we want to keep relative references. The forecast and the actual demands, we want to keep those relative reference, so as we copy this cell down, Excel changes which forecast and which demand it uses in the calculation. What we do not want to change is the alpha. So I'm going to go to the alphas, and I'm just going to click that F4 key, lock in that alpha, because there is one alpha for all these calculations. Push enter, and I copy this cell down. And I see it's all going to be the same because I don't have a value for alpha right now. Okay. So now I'm going to find those mean, the absolute errors. So equals to ABS for absolute, demand minus forecast, and close that bracket. Copy that down, and I have all my absolute errors. Next step is I need to now calculate or designate a cell to do this calculation for the mean absolute deviation, or MAD, equals to average against mean of those absolute deviations. And so I select all those cells where those absolute deviations lie, reside, were calculated, were placed in, where you can see them, where they exist, blah, blah, blah. Okay, so now we're all set. We've got our error calculation. We've got our cell for alpha. We're set to go and do this calculation. So go to data, go to solver. I'm just going to clear everything out. And the set objective, wherever my error calculation is, I want to make sure I minimize that. Which cell do I want to change? I want to change that alpha. Now, I know we started off with no value in alpha, and that looked a little unnerving because the formulas didn't change. If that causes you any kind of stress or confusion, just put a placeholder value in there, 0.5, 0.2, 0.1, whatever the heck it is. Doesn't matter. You can put a placeholder in there just so that you can kind of see if your formulas are matching up. I sort of rolled the dice and hope that I'm right. Our constraint, as we're going to add, is that alpha has to be less than or equal to 1. It also has to be greater than or equal to 0, but I know I have a box, make unconstrained variables non-negative, that helps me out in that regard. Okay, so by checking that box, I've ensured that that alpha is a number 0 or higher. Okay, it is nonlinear. I click solve. Boom, no error message. Awesome. Click OK, and I get an alpha of 0.1335555. Okay. And now we can look at that alpha through the context of what we learned in midterm number 1. Is that alpha? Is this model responsive to demand? Not responsive to demand? I look at that alpha. Closer it is to 1, the more responsive it is to the most recent period's demand. Here, not so much. Okay. So that's it. There's our little forecasting in a nutshell, and that's essentially all you'll be expected to know. Okay, so for mappy, we're going to go equal to the absolute value of the error divided by demand times by 100 to express it as a percentage, and then take the average of all these absolute percentage deviations. Okay, so it's equal to ABS, and then bracket. Now we note that the denominator here is error, so I'm going to do that as a calculation within this absolute value operator, so second bracket. Error just being demand minus the forecast. Close that bracket. That's our numerator. We're going to divide it by error. Now divided by demand. We're going to divide by demand. I'm going to leave that demand within the absolute value operator. Most of the time, it doesn't matter. Most of the time, you're dealing with sales or quantity sold. Extremely rare that that's a negative number. This case is a little different than those in that here we're dealing with net income. And net income can be zero. So we want to express this as get rid of all the negative values. And we multiply it by 100 to express as a percentage, and then I click enter. Copy that all the way down. Corner, double click. Now, scroll down looking for weird numbers because there's one quarter here where Best Buy didn't make any money. So I'm just going to quick and dirty just enter a 0 in there. Okay? It's just an uncalculable number. We just want to ignore it. Okay? And I get rid of this div 0 here because there's no corresponding demand related to that particular forecast. Okay, now I'm all set. Holy cow, looking past there. Whoa. There's a forecast that was really wrong. Okay, so now let's take the average. So equals to the average of all those calculations. Control Shift down, close the bracket, boom, boom. Right? And I get 225%. Okay, so clearly something's gone pretty badly with this particular model. We're missing something, right? There's either an overall trend that we're not capturing with our weighted moving average model, other factors at play. Something is definitely happening that we're not capturing with these models. And so perhaps other alternatives might be more appropriate. A trend-adjusted exponential smoothing model might work. An exponential smoothing model in general might work, which we'll do next. There's clearly something else that fits. We capture some of the flow of net income here, but we're not capturing all. Now, net income's a little tricky one versus sales in that there's typically a lot of other things that are at play. Okay, anyway, pretty interesting result there.